Hello everyone. In this video, I'm going to show you how to create a REST API from scratch with Node.js, Express.js and TypeScript. I'll be using Amazon Code Whisperer as my AI coding partner to help me write code faster. Amazon Code Whisperer is a generative AI tool and is free to use. I believe the best way to learn something is to first understand the concept and then apply it through exercises. So, I'm going to first spend some time talking about the basic concepts of REST API, help you to understand how Express.js works, and then we'll create a very simple calculator API in TypeScript. At the end of this video, I will give you some exercises and resources for you to continue learning. A REST API is a way for different software or devices to talk to each other using the same rules and language as the web. For example, when you buy something online, the website uses a REST API to ask the payment system to process the payment. A REST API uses web addresses to identify different things and web commands to do different actions on them. A REST API can send and receive data in different formats, such as text, pictures, or code. Data first flows from client to server. A client could be a web browser or another service. You will be creating a REST API which runs in the server. The REST API will listen for a HTTP request from the client, process the information from the request, and send back a HTTP response. This is very similar to functions in any programming languages. You take an input argument, process the input, and return the output as a result. Except that in REST API, you are setting up a server which listens to requests continuously. So, what information is in the HTTP request? Every HTTP request has a URL, and URL stands for Universal Resource Allocator. It is a unique identifier used to locate a resource on the internet. URLs consist of different parts, including protocol, domain name, port, path, and optionally, query parameters. Each request has a method. It could be get, post, put, delete, patch, etc. And these methods are standardized in REST API. A request also contains headers. These are metadata describing the request and is represented in key value pairs. There are standard headers and custom headers. For example, accept is a standard header, which specifies the response data format the client is willing to accept. The content type header specifies the data type of the request body. There are other headers which contain the authentication information. The request body could be a JSON object, which is very common. It could also be a file or just a text. When you're sending a request body, you need to specify the data type of the request body in the content type request header. In a HTTP response, it should contain a status code. These status codes are also standardized. For example, 200 means OK, 404 means not found, and 500 means internal server error. Response also contains headers describing the response. These headers could be standard or custom headers, similar to HTTP request. For example, the content length header specifies the length of the response body. The content type header specifies the data format of the response body. The response body could be any data format which matches the content type response header. A common data format is JSON, but it could also be a file, text, or any other format. Summary: when you're creating a REST API, you're creating a service which listens on a particular port. When a request comes into a REST API, you extract the information from the request. For example, you may need information on the path and query parameters. You may want to see what method the client is using, what headers the request has, and what's in the request body. And then you do some magic, process the information, and then send back the response. In the response, you provide a status code, set the headers, and then include a response body before you send back the response to the client. Express.js makes it very easy to set up a server for the REST API. You can set the Express server to listen on any particular port. It gives you some ready-made features and shortcuts to help you extract the information from the request and then send back the response. Before we begin, let's see what we want to do with this calculator API. The REST API will have 4 simple endpoints. It will have one endpoint for health check, one endpoint to get all calculations, one endpoint to get a calculation by an ID, and another endpoint to create a calculation by providing a request with an operator and 2 operands. Let's fire up VS Code now and start coding. My VS Code is opened up and I'm in an empty folder named calculator. The first thing we want to do is to check whether Node is installed. We can type node -- version and then enter. Mine shows version 16, but you can also use version 18 or version 20. We initialize the Node.js project with npm init-y. Y means yes to all the default settings. So you can see that the package.json file has been created. If you open it up, you will see the default setting for this Node.js project. So now we'll install the dependency for Express.js. So we can type npm install express. Express is the name of the package for Express.js dependency. You can see that the dependency for Express.js has been installed. Now we'll install the dependencies for TypeScript. We need to install 2 dependencies. One is for TypeScript, and the other one is the type for Express.js. Because Express.js is written in JavaScript, so we need to install a separate package for the type information for Express.js. We'll type npm install --save -dev TypeScript, and then add types /express. --save dev means that we are saving these dependencies as development dependencies. Because TypeScript will be transpiled in the JavaScript at runtime, so there's no type information in the compiled JavaScript. So we don't need TypeScripts or any types for runtime. And the only runtime dependency will be the Express.js dependency. If you go to the package.json, we can see that the TypeScript and the Express types package has been installed. So these 3 packages are the minimum needed to create a Node.js project with Express.js and TypeScript. But for convenience, we'll install another dependency called nodemon. Nodemon helps us to watch for any changes in the JavaScript file, and then it will restart the Node.js application automatically. If you don't use nodemon, you can always stop and then restart the application manually whenever you make any file changes. We install nodemon with npm install --save -dev nodemon. Again, we don't need nodemon during runtime. Nodemon is only used for development. You may wonder, how do I know the names of these dependencies? You can search for their names in npmjs.com. Here's the Express.js page on npmjs.com. The name here is the name of the package for Express.js. You can find the instruction to install Express.js right here. npm I is equivalent to npm install. If you hover your mouse here, you can see that it says this package has TypeScript declarations provided by @types /express. If you click into it, this is the same package that we installed for the types for Express.js. If you search for TypeScript here, you can see that the TypeScript show up as the first option, and this is the exact name that you will need to install the TypeScript package. The same for nodemon, and this is the exact name that you will need to install the nodemon package. Now we'll initialize the TypeScript project. Type npx, not npm, tsc -init. tsc is a program provided by the TypeScript package. This command will initialize the TypeScript project, but you can also use tsc to transpile TypeScript files into JavaScript. And npx is a package runner. it will run packages installed in the Node modules folder. If you go to the Node modules folder, under .bins, you will see the tsc file. The npx tsc is actually running this file under your Node modules folder. And you can also see that the tsconfig.json file has been created. Let's open it up. This file contains the default configurations for the TypeScript project. You will keep everything as they are, but there's one parameter that we need to add. This is called the outdrive parameter. We'll uncomment it and then modify it to dist. What this means is that when we transpile all the TypeScript files into JavaScript, we're going to save all the JavaScript files in this dist folder. If you don't set this folder, then all the JavaScript files will be saved alongside with your TypeScript files, which will make it a little bit messy. We'll save this file and then close it. I will also close the package.json file. Now we'll create a folder named src and we'll keep all the source code in the folder. And we'll create a file named app.js. This file will be the entry point of our Node.js application. To create a REST API with Express.js, we first need to import Express into this file. You can type import Express from Express. The second Express here refers to the Express package that we install as a dependency. And the first Express here is a variable that we want to assign the Express package to. And then we can create the Express application with const app equals Express. And we're executing this Express as a function. This will create Express application. And then we can set the port number as 3000. To set up a server, we need to have the Express application listen on this port 3000. To do it, we can type app.listen. So listen is a function of the Express application. It takes two arguments. The first one is a port number, and the second argument is a callback function which will execute when the server runs. We are just going to print out this message saying that the application is listening at this particular port. So this is the bare minimum you need to set up Express server. Node.js cannot run TypeScript files. If you try to run it, it will give us an error. We can give it a try. Node source/app.ts. So it's giving us an error. To run the TypeScript file, we need to first transpile the TypeScript files into JavaScript. To do it, we can run npx tsc. As you can see on the left-hand side, there's a folder named dist. It was created with a file named app.js. This app.js is a transpiled file from the TypeScript file. Remember in the tsconfig.json file, we set the outdrive to be this folder named dist. When it transpiles the files from TypeScript into JavaScript, it's going to save all the JavaScript files in this folder. So we can now run the JavaScript file. We can run it with nodemon. We can do nodemon dist/app.js. It doesn't work because nodemon is installed in our Node modules. We need to run it with npx. So we can type npx nodemon dist/app.js. So you can see that nodemon is going to monitor this file called app.js. But what happens if we modify the TypeScript file? Nodemon is not going to know because after we modify the TypeScript file, we have to retranspile the TypeScript file into JavaScript. To do it, we can use a function from the tsc command to watch for any changes in the TypeScript file, and then automatically we transpile the files into JavaScript. To do it, we can type npx tsc -w. W means watch. TSQ is going to watch for any changes in the TypeScript file, and then we transpile them into JavaScript. So we can combine this tsc-w command with the nodemon command, but to type it every time is going to be pretty tedious. We can save this command into the package.json file under the script variable. So let's do it. So anything under the script is a custom script that you can run with npm run. We can create a script named def, and then the command would be tsc-w & nodemon dist/app.js. So the command under the script file would be automatically prefixed with npx, so do not need to include npx into the script commands. To run it, we can do npm run dev. So now whenever we have any changes made to the TypeScript file, TSC is going to automatically retranspile the files into JavaScript, and nodemon is going to watch the JavaScript files for any changes. So let's close the package.json file. Our server is now listening to HTTP requests, which are coming to port 3000. We can send an HTTP request to our server to test it out. I'm going to use Thunder Client, which is a VS Code extension, but you can also use Postman or curl. I'm going to send a GET request to our endpoint at localhost port 3000. It gives us an error because we haven't set up Express to process requests on any path. To fix that, we can add an endpoint to our Express application. We can do app.get. Get is a function of the Express application. It takes two arguments. The first argument is the path, and the second argument is a callback function. This callback function has two arguments. The first one is the request, and the second one is the response. We can send back the response with response.send, and the argument you provide is the response body. You can simply send back hello world. We can test it out again and see what happens. Now it's working. Sometimes you may see endpoints which take an arbitrary variable, such as an ID on the path to get a resource by ID. We can also do that with Express.js. We can add another endpoint and see how it works. This time, instead of a slash, we're going to do /:ID. The colon designates the ID as a path parameter. This means that whatever value that you set in the URL after this /, the value is going to be assigned to this ID variable. You can send back a message with an ID on the path parameter. You can give it a try. You can add a node. We send a request on the path node, and node is going to be assigned to the ID here, and therefore you will see the response as hello node. We can also extract other useful information from the request object. I'm going to print them out with console log, and then we can take a look at them together. We can access the query parameters at the query property of the request object. Because request query is an object, that's why I need to convert that into a JSON string with json.stringify. To access the headers, we can use the headers property on the request object. And to access the method, we can use the method property on the request object. And then we can give it a try again and see what happens. If we look at the console log, we can see that the query parameter is an empty object, but it prints out the headers and the method. We can provide the request with query parameters and see if it prints out as we expect. As you can see, the age query parameters is logged in the terminal, as we expected. We can also sample a different status code or add headers to our responses. To add a status code, we can do response.status. Say we want to sample a status code of, say, 202. It will send a response with a 202 status code. And to set headers in the response, we can do .header. There are two ways to do it. If you only have one header to set, you can do it like this. The first argument is the header key, and the second argument is the header value. But if you have multiple headers to set, you can provide it as an object of key-value pairs of headers. Like so. And we can test it out. Now you see the status code becomes 202. If you look at the response header, you can see that our custom headers are being added as well. You may wonder, how do I know what methods or properties the Express application or the request and response body have? Usually, the library's API documentation will have the latest information on this. This is the API documentation for Express.js. As you can see, it lists out all the properties and methods the Express application have. If you go down the list, you will see the request object, and there's all the properties listed here, as well as its methods. The same goes for the response object. Usually the best source of information will be in the library's API documentation. Sometimes the library may have new features the other tutorials may not be up to date on. Therefore, it's very important to get used to reading API documentations if you want to be a good developer. One thing to pay attention is that Express evaluates the request from top to bottom. Whenever you find a request with the matching path and the request method, it's going to execute the corresponding callback function and send back the response. If we add a health endpoint here, this health endpoint is not going to be called. We can give it a try and see what happens. We're going to try to send a request to this health endpoint. You can see that the response is not what we expected. This is because when we send a request on the path health, Express is going to evaluate from top to bottom. When Express is evaluating this path, it considers the word health is the ID, and it's going to execute this callback function and respond as hello health. One way to fix this is to put a more specific path above the one with more generic path. For example, we can move this health endpoint up, and then it should execute as what we expected. Now returns OK. Another way that we can do is we can prefix the path to avoid any conflicts. For example, we can prefix this as calculator. So if you want to execute this logic, then you have to send the request to the calculator/ID endpoint. Another problem you may face is that as your REST API gets more complex, you may have more and more endpoints, and putting them all in one file may become unmanageable. There's a feature in Express.js called Router, which will help you organize your endpoints easily. Router is like a map that tells Express.js what to do when someone visits a certain path on your website or app. For example, you can have a router that handles the calculated path and another router that handles the profile path. Any request with path which start with calculator will be routed to the calculator router. For example, /calculator or /calculator/ID. And the same goes for other routes like profile. Each router is like a mini Express app, and it can have different HTTP methods, such as GET or POST. Let's see how we can use router. By convention, routers are typically stored in a folder called routes. We have two routers, one for health and one for calculator. Let's start with the health router. To set up a router, we can import the router module from the Express package. And then we can create a router with const router equals router, and execute the router as a function. Router works a lot like Express app, so we can copy the code from app.js and paste it here. Then change the name from app to router. Since we're going to prefix the health route with the word health, we can eliminate the word health here. I'm also going to change the response from the string OK to a JSON response. And then we need to export the router so that we can use the router from another file. Now we can work on the calculator route. We're going to do the same. Import router from Express. Const router equals router, and execute router as a function. Now we can copy the code from app.js and modify it here. We're going to copy this too. And change the name from app to router. The first route will be prefixed with the word calculator, so we're okay here. Since this route is going to send back all calculations, I'm going to send back a JSON object. The data will be an array, and I'm going to just put some dummy data in it. This second route is going to get a calculation by its ID, so I'm going to send back a JSON object as well. I'll remove all these console logs. We also have one more route to create a new calculation, but I'm going to keep that for a little bit later. And then we have to export the calculator router so that we can use the router from another file. I'm also going to create a file named index.ts under the routers folder. And I'm going to export the health router and the calculator router from this file. This will make it a little bit cleaner to import the routers from another file. So the word s here is going to rename the variable router into a different name here to avoid the naming conflicts after we name them when I'm exporting them. Now we can close these files and then go back to the app.ts. We will import the routers into this file. To use the router in the Express application, we will do app.use. Use is another function in Express application, and it takes two variables. The first variable is the prefix for the route. In this case, it will be health. And the second variable is the router itself. And we'll do the same for the calculator route. And now we can try out our endpoints with the routers. I'm going to test the health endpoint first. And it's working. And then the calculator endpoint. It's working too. This gets all the calculations. And now the get calculator by ID. Let's give it ID of 1, 2, 3. And now it's working as well. Another feature which is very useful in Express.js is middleware. Express.js middleware is a way of adding extra features or functions to your website or app. Middleware is like a helper that can do things like check your password, change the format of your data, show an error message, or pass a request to the next helper. Middleware is a function that runs in between the request and the response. You can have many middleware functions for different purposes. For example, you can have a middleware function that runs any code that you want, changes the request or response data in some way, ends the request and response cycle, and sends the result back to you. Middleware can be at the application level, router level, or even at the path level. Let's see how we can use middleware in our Express application. We can use middleware to log all the requests coming into our REST API, which is a pretty common application. To add a middleware, we can do app.use. It only takes one argument, which is a middleware function. The middleware function has two arguments. The first argument is the request, the second argument is the response, and the last argument is the next function. And we can log the request with console log. We're going to log the request method, the IP address, and the path. To get the IP, there's a property called IP in the request object. To get the path, you can use the property called original URL. Remember, at the end of the middleware function, you need to execute the next function. If you don't execute the next function, the request will stop here and never returns, and the client will never get a response. The next function signals that this middleware has finished execution. It's going to pass it to the next middleware or the business logic. Keep in mind that since Express.js evaluates from top to bottom, and this middleware needs to go between the request and the business logic. That's why we have to add a middleware before we add the routes. Let's give it a try and see if it does what we expect it to do. And then we can check the console log. As you can see, it prints out the request method, the IP address, as well as the path. You may realize that the IP address has a prefix of : FFFF:. This is the IPv6 prefix to an IPv4 address, and is used to represent the IPv4 address in the IPv6 format, and is completely valid. This middleware is set at the application level. Whenever there's a request coming into the health path or the calculated path, this middleware will be executed. We typically don't want to create a middleware in the app.ts file, because if there are lots of middlewares, this file will get very messy. So I'm going to create a folder named middlewares and then move my middleware into that folder. I'm going to create a file named log.ts for this middleware. And then I'm going to copy the code over there. One problem is that although we know the first argument is request, second argument is response, and the last argument is the next function, TypeScript does not know that. So we have to add a type annotation to this function. We can import a type annotation from Express and then use it in our function. And then I'm going to create a file named index.ts to organize our middleware exports. And now we go back to the app.ts file and update our code. We can try it out to make sure it still works. You can see that the request is logged to the terminal. And then we can try the calculator route. This is working as well. We can also add the middleware at the router level as well as the path level. Let's try to add the logger middleware to the calculator route and see what happens. To add the middleware at the router level, we can do router.use and then the middleware function. We can also add the middleware at the path level as well. Just add it before it runs the business logic. And we can add as many middlewares as we want. In this case, we add a logger middleware at the calculator router level. And we added 2 logger middlewares at the get all calculations path. If we execute the HTTP request to get all calculations, the request is going to log 4 times. One from the application level logger middleware, one from the router level, and 2 from the path level. And if we make a HTTP request to get a calculation by ID, the request is going to be logged 2 times. We can give it a try and verify if this is correct. So this is the request to get all calculations. You can see that the request is logged 4 times. If we make a HTTP request to get calculation by ID, the request is logged 2 times. And this is what we expected. I'm going to remove the logger since we don't need the loggers. I'm going to remove the logger since we don't need to log I'm going to remove the logger on the router level since we don't need to log the request multiple times. We're also going to add another middleware to add the timestamp of the request, since it may be helpful to know when a request comes in, and we may need the information in our business logic. We're going to create a file named time.ts. I'm going to first import the types that we need for the middleware function. I will name the function add timestamp. So you can see that we try to set a new property in the request object called timestamp, but it's highlighting red. It says property timestamp does not exist on type request. The reason for this error is that the request object does not have the property named timestamp, and therefore TypeScript thinks we are making a mistake by setting a property which does not exist. To overcome that, we can create a declaration file to declare that this timestamp property actually exists. We can add a file called global.d.ts. I named this file global, but you can use any name you like as long as the file ends with .d.ts. To declare that the timestamp property exists in the Express module, we can do import Express declare module Express interface request with a property of timestamp, and this has a type of number. What this means is that we are merging the property timestamp with the properties existing in the request object. If you go back to add timestamp middleware, the error is gone, and TypeScript recognizes that it's a type of number or undefined. Now we'll add this middleware to the index.ts file. And then we'll add the middleware to our application. We'll add this middleware before the logger middleware, since we may need the timestamp information in the logger. We'll add the timestamp information in the logger and the responses from the health endpoint and the calculator endpoints. It is giving us a type error, but we can annotate the request argument with the request type in the callback function. And the error goes away. We'll do it for the calculator routes as well. and then we can test it out. The timestamp is included in the response as well as logged to the terminal. We try to calculate the route. And it is working as expected. And this is working as well. Another useful feature of middleware is to handle errors. Express.js has a default error handler to handle any uncaught exceptions, but it may not be what you want. Let's see how the default error handler behaves. We can go to our health endpoint and then throw an exception here. And then test it out and see what happens. And our REST API responded with an error message with the entire stack trace. Sometimes you do not want to expose your code information to the client. To override the default error handler, you can use your own custom error handler. Let's see how we can do it. We're going to create a new middleware called error handler. We'll first import the types. Unlike other middlewares, the error handler middleware has 4 arguments. The first argument is the error object. The second argument is the request. The third argument is the response, and the last argument is the next function. If you provide a middleware function with 4 arguments to the Express app knows that this is an error handling function. And it is going to use the custom error handler instead of the default error handler. This error handler is going to return a status of 500 with an error message. We export this error handler in our index.ts file. And then we add this error handler to our Express app. And we need to add error handler after adding all the other middlewares and routes. App.use error handler. And let's try it out and see what happens. And it is working as expected, and it is returning only the error message. And the stack trace is printed in the terminal, which is not exposed to the client. Now it's time to add the post request to create a new calculation. We're going to add it to the calculator router. Instead of router get, we're going to use router post to handle a post request. For now, we're going to simply respond back with the request body and see if we can access the information from the request body. Let's give it a try and see what happens. We're going to send a post request to the calculator endpoint, and we're going to set the request body. We have operator plus operand 1 and then operand 2. You can see that the request body is missing in the response. Let's do a console log and see what happens. You can see that the request body is undefined. Let's check and see if we made the request correctly. You can see that it sent a post request to the calculator endpoint. It set the content type header correctly, and the request is a JSON object. It looks like our request is correct, but why are we not getting the request body in Express.js? This is because by default, Express.js does not set the request body. To set the request body, we have to use another type of middleware called body parser middleware. Let's see how we can do it. We can do it with app.use express.json. What this does is that if you send a request with a JSON request body, Express is going to parse the request and set it in the request.body property. There are other types of body parsers that we can use. For example, it has the text body parser. It has the URL encoded body parser to parse the form data. But using only JSON is sufficient for our use case. And now we'll give it a try again. And now the request body comes back with the response. Now we can go ahead and finish the calculator endpoint for the post request. One problem is that TypeScript does not know what type of data is in the request body. If you hover a mouse over the request.body property, you will see that it has any type. And our operator, operands also have any type. In order to set the type correctly, we have to provide the type information for the request body. Let's first create a type information for the request body. We're going to create another folder called types to keep the type information. Inside that, we'll create a file named calculator.ts. And then we'll create the type information for the request body here. We have the operator with a type of plus. minus, multiply, and divide. We have operand 1, which is a number, and operand 2, which is also a number. We add a file named index.ts to export the type information here. And then we can go back to our calculator router. We can set the type information in the request type. The request type from Express is a generic type. You can see the first argument in the generic type is the parameters dictionary. The second argument is the response body. And the third argument is the request body. We can provide a more specific type to override the generic type. Since we don't have any parameters, we can set the parameter type as an empty object. The second argument is the response body, which we just set it as any for now. And the next one is the request body. This will be our calculator request body type that we just created. If we hover our mouse over the variables, you can see that the type is now set correctly. Now we can complete our function. We'll declare the result variable as either number or string. Do a switch statement on the operator. And Code Whisperer just gave us all the code that we need, which is very cool. And then instead of send back the request body, I'm sending back the result. Let's try it out. The addition is working. The subtraction is working as well. Multiplication is also working. And the division is working as well. If you use an invalid operator, this is working as well. But sometimes we may not want to respond back with a 200 status code if the operator is invalid. Also, if somebody forgot to include the operands, it may cause an issue. For example, if we only provide the operand 1, and the result is null, even though the status says 200 OK. It is very important to always validate the request from the client, because the client can send anything to your API, and you should never trust the information coming to your API endpoint. To do that, we can create a validation function to validate the request, and then run the validation function as a middleware. Let's see how we can do it. Let's create a file called calculator.ts under the middlewares folder. Let's import the type information from Express. We'll call this function validate calculator request. And we'll set a more specific type to the request, similar to what we did in the post request for the calculator. The first argument is the parameter dictionary, which is not needed for us. Second argument is the response body, which we can put as any for now. And the third argument is the request body, which we have a calculator request body type that we created. We first get the request body. We check that if operand 1 or operand 2 are not numbers, we'll return back an error message to the client. If type of operand 1 is not number, or type of operand 2 is not number, we'll return an error message to the client. And then if operator is not, and if operator is not plus, minus, multiply, or divide, then we also return an error message. Otherwise, we can proceed to run our calculation. And this is our validation function for the calculator request body. We can export this to our index.ts file. In the calculator route for the post request, we can add the validation function here as a middleware. And we can try out our validation function to see if it works as we expected. And now it seems to work. And this is working as well. And the correct message will give us a correct response. This is all I have for you for the calculator API, but you don't have to end here. There are a few things you can do to improve your calculator API. You can add paths in your calculator router to handle put and delete requests. Also, I want you to find out how to get cookies in the request and set cookies in response. I also want you to find out how to check if the request connection is secure. That means it's using HTTPS. And you can find the answers to this from the API documentation. I'm going to put link to Express.js API documentation in the description below. I want you to get into the practice of reading documentation. A good developer is also a good reader. Tutorials and Stack Overflow can only get you so far. Reading the documentation may take a little bit of time, but this will help you to understand the nuances and avoid any pitfalls when you're using the tool for your application. I'm going to put a link to GitHub with the completed code in the description below. If you have any issue creating a REST API, feel free to reference the repository or put a comment below. I hope you enjoyed this video. Feel free to comment below on what you have created and what you have learned today. If you like this video and find this video helpful, please give me a like and subscribe, and share this video with others. This will give me more motivation to create new videos for you. Thank you for your support, and goodbye, and see you in the next video.